Our previous session terminated right in the middle of talking about our first example of a context-free grammar that we labelled just simply G1, G for obviously for grammar and 1 because it's our first example. So just going straight on, the start variable for that grammar was A, okay? And the terminals were 0, 1 and hash. Okay? Now some really basic ideas. The grammar, what's a grammar for? You know, you've got an idea now what it is. You know, whether it's what I've been calling rewrite rules, and its variables and its terminals. You know, its set of rules, transposition rules or rewrite rules, or and the start state. So those four things. Now, when we come to the formal definition of a context-free grammar, we will use those four things. We will create a for-tuple, but I'm getting a little ahead of myself. All right. So what's a grammar for? You know, what's its purpose? Well, basically, it describes a language. Well, in effect, it generates the language. The set of all possible strings that grammar can create, you know, all possible. That is the language. You know, remember what a language is? Just a set of strings. Okay? So the language that's generated by that grammar. So that means that you can look on grammar as the description of that language, because it's the language that the grammar generates. Okay, that's probably the basic idea of the whole chapter. So you know, really absorb it. Okay. Now, how do you go about generating a string? And remember what a string is in this sense. It's just a sequence of symbols that are terminals. You know, they can't be substituted or expanded or rewritten anymore. That's why they're called terminals, because they terminate at that symbol. You can't rewrite that symbol to something else because it's a terminal. You know, like the word terminus, like the end, right? So terminal, the adjective of terminus, the end. Right. So how do you actually go about generating a string? You know, string of terminal symbols. How do you do that? Well, three-step process, sort of. Okay. First thing is you write down your start variable. You always start with your start variable, and that will be one of your variables. Traditionally. The start variable is capital letter S for start, obviously. Okay, so you write down the start variable, and that start variable it's usually written S, but you can find it conventionally. It's the left-hand side. That's LHS, left-hand side of the first rule in your R. R being the set of rules, the transposition. So the word has been using. Let me just check. There's so many labels for the rules. Substitution rules. Very quickly, Sipser just uses the word rules. Doesn't bother with the previous label. You know, what kind of rules. So we call substitution rules. So okay. So you write down your first variable, and it'll be the start variable. So you go looking for it, and you look at the top rule. You look at the left-hand side of that top rule in your list R of rules, substitution rules, and it's usually S, capital S. So you write down S, okay, and then you loop through 2 as much as possible until eventually you can't go any further. In other words, the string that you're generating using these substitution rules is just full of terminal symbols. There are no more variables to be expanded, to be substituted for. So how to use this second step? Well, you find a variable in what you write down, and that'll become clear in a minute. We'll do examples, so you know what's happening. So you look for a variable in what you've written down, and then you find a substitution rule whose left-hand side, the variable on the left-hand side, is equal to the variable that you've written down, that you've chosen to substitute, to expand. And then you take the right-hand side of that rule that you've chosen, and then you replace what you wrote down, the variable that you wrote down. You replace that variable by the right-hand side in the rule. Okay? And then you just keep doing that. You do step 2 umpteen times until eventually all the variables in what you wrote down have disappeared. They've been replaced by terminals. And once there are no more variables left to be substituted, replaced, rewritten, so that all your symbols in your string that you're generating using the rules, they're all terminals. Okay, then you stop. Right? So step 3 is basically just repeat step 2. Okay, until there are no variable remains. They're all terminals. Now in a minute, I'll give you an example of how to do that. Right? So here's an example of a string. Now they're all, if you look at all these symbols here, they are all terminals because they all belong to the set of terminals, right? 0, 1 and hash here. Okay? That is an example of a string generated by the grammar G1. Okay? And the grammar is what? Well, it's the list of substitution rules. Well, it's a bit more than that, but basically that's the essence of it, right? Okay. Now this sequence, this going, looping through step 2 until you eventually get a string that comprised only of terminal symbols. There are no variables left in the string that you're expanding, that you're in the process of substituting a variable for the right-hand side of a rule. If you're not clear on that, you soon will be, okay? Because it's a fairly easy process. You'll see in a minute the next square will actually do one. Okay? But that sequence of rewriting or substituting a variable, one variable, for the right-hand side of the rule, you keep that sequence of doing that is called the derivation, right? And it ends. The derivation ends when you come to a string whose symbols are all terminals. Okay, so you would start with the start variable, so usually capital S, and then substitute. You go through this step 2 umpteen times until eventually you terminate. You get a string all of whose symbols are terminals. Okay, and that sequence is called a derivation, because what you've done, you have, from the grammar, you have derived the string of terminals. Okay, so you've used the grammar to derive the string. Okay. Now this is an example of a string full of terminals. These are all terminals, terminal symbols, 7 of them. Well, 3 different ones, but 7 in the string. The length of the string is 7. Okay, and you generated this string by using the grammar G1. And here's like the history, in a sense, of the derivation. This is the derivation, starting with the starting state. Well, in this case it's A, not S. Okay, A is the start variable. Okay, for this grammar, but usually it's capital S. But it's only a detail. So here's the derivation of this string using this grammar. And let's see. Now, what are we doing here? Well, this here is just one of the rules, one of the substitution rules. So, so you start with the start variable. That's A. Okay, and then you look at the rules, and you find a rule whose left-hand side is the same as a variable that you're looking at amongst the variables that you've written down. And one rule is that A arrow 0A1. Okay, so you substitute or rewrite. So you remove the A, if you like, and then you replace it by 0A1. Okay. Now that's a terminal. That's a terminal. Can't do anything with those. Can't rewrite them. Can't substitute them for anything because they're terminals. But the A is a variable. But so you can replace that. You can rewrite. You can overwrite it, if you like. You can substitute it for something else. Well, we could use the same rule again. Yeah, this rule, in fact. And so we can substitute or rewrite A to become 0A1. So this middle 0A1, right? Now we're trying to derive this, okay? So we do the same thing again. So so we substitute A for 0A1, okay? So now it's the middle 0A1. Right, now there's another rule. Okay, now we're getting pretty close to this. You know, this is what we have written down. The current string of symbols, if you like, is this. Now we're getting close to what we want. So now we want this A to become a hash, but you can't. There's no rule that takes you directly from A to hash. But there is a rule, A arrow B. And then from B, you can get, there's a rule B arrow hash. Okay, so let's just substitute A for B. So we use the rule A arrow B.